In this video, I will show you how to use the compressed fibrous model in AlphaCell. So first we open AlphaCell and we will create a new study like compressed fibrous, for example. And then we will load a fibrous material. So I have no material in my database, so I will open the default database that comes with AlphaCell, for example, the automotive.ref1. Then I choose one fibrous metal like this field and I double click on it or click on the plus button to add it to my shelf here, and I can reload my own database, so which contains only this fibrous, and I can drag and drop it to my tube, go to the parameters list, so I can here see the parameters of this JCAL material with an elastic isotropic model for the skeleton part. Here are all the parameters. Here we can compute sun absorption or sun transmission, but we will stick to sun absorption in normal sun incidence and not in diffuse field for the moment. So I click on it to have this sun absorption in normal sun incidence computed, and I will click on this button to be able to compare curves in the future. So now that I have this fibrous material, I will create a new material, which will be the compressed one. I will call it compressed fibrous. And I will choose the heterogeneous model, the compressed fibrous one. So I remove this one from my tube without changing anything, but I drop it to the host as it will be the material that I will compress. Okay, and then I have to choose a compressional rate, like for example 10% or 20% of, or 50%, for example. And we can see that the parameters are changing if we compare to the original material. So here we have a JCAL model, but the compressed fibrous is only working with a JCA model. So the information about the static thermal permeability is dropped here. Okay, now how the compressional rate is computed. So we use this formula, thickness before compression minus thickness after compression, divided by thickness before compression, and everything is multiplied by 100. The model used behind the this compressed fibrous model is inspired and based on the work by Bernard Castagnette and colleagues for the acoustic part, and on the work by Gibson and Ashby for the elastic part. And here, if we have the original thickness of my material, so 20 millimeter, the thickness of my compressed material for 50% will be this one, so half the thickness. And with AlphaCell, you can also use negative compression rate, like -50 would be this kind of material, so not compressed but extended. And we can just have a look. -50% will be this kind of material with these parameters. Okay, for the moment we'll keep to 50%, and we can do something better, which is compute the compressional rate as a function of the thickness here of the material. So the default thickness of the original material is 20 millimeter. Okay, and the value of this variable is t, so I can enter the compressional rate function, so 100 times, so 0.02, which is the default thickness of the uncompressed material in meter minus t. So here in the formula we use meter, why here it's written in millimeters. So this is why I have 0.02 minus t divided by 0.02. And we have a compression rate of 0, but if I change, for example, value, 15 millimeter, I have a compression rate of 25, 10 millimeter, I have a compression rate of 50%, which is coherent. And I can compute the sun absorption coefficient of my compressed fibrous. And if you have a panel with a lot of different compressional rate, remember that you can use the assembly panel to compute the sound absorption or the sound transmission of this panel with different compressional rate, different thicknesses of the same material.